Okay, everybody, look at this one. Lesson 5.10, factoring by grouping. Now, lucky for you, you've already been doing this. This is the way, the method that I use and that Mrs. Hamilton uses anyway, and that's what I've been showing you for the past several lessons. But what this lesson in the textbook points out to us is that if two factors are being multiplied by the same thing, you can group those together, the 2 and the negative b, because both of those are getting multiplied by the aforementioned items in parentheses. That process, those steps, you've already been doing that. Not difficult at all. Let's look at a couple of examples though, just to be sure that you're clear. So 2c plus d, negative b, c plus d. The 2 and the negative b are both being multiplied by c plus d. Therefore, they can get grouped together and be multiplied by c plus d here. One that's kind of tricky though, that's an example 1 type problem, looks like this. 3b, b plus 1, looks like this. First thing I want you to recognize, b plus 1 and 1 plus b are the same thing, right? They're the same thing, only written in reverse. This negative with no number means you have a negative 1 floating in front of this. It's kind of like a placeholder. In any case, you can now group your 3b and your negative 1 because both of them get multiplied by b plus 1, or you can call it 1 plus b, whatever. And there's your factors. So be on the lookout for that. Here's another one that I find interesting. Example 2. Five b minus 4 plus 3b 4 minus b. Now, unlike the one above, these two components are not the same. This is a positive b, this is a negative b, this is a negative 4, and that's a positive 4. But if we flip the sign of this, make it a negative, that flips those two signs, now causing these to be identical like we want them to be, making it doable for us to group these items together. 5 minus 3b and b minus 4 is now correct. Where it gets tricky is in examples 3 and 4, where they don't already have stuff pulled out for you. Examples 3 and 4, I'm going to get started on those. Here's example 3. AB minus 2B plus AC minus 2C. Okay, let's look at this as it sits right now. Do these two components share anything? Yes, they share the B. Let's group these together. These share the C. Let's group those together. If I pull a B out of here, I end up with A minus 2. And if I pull a C out of here, wouldn't you know it, I end up with A minus 2. Isn't that convenient? Since both of these two pieces are being multiplied by A minus 2, I can group them together, just like we've been doing in previous lessons. And then express the a minus 2 only one time. Their example has one like that for you. Sometimes, though, we're going to find that there are other ways to factor, and this is really going to be trial and error for a while for some of you. Example 4, for example, is one I want to show you. It looks like this: 9p squared minus t squared minus 4ts minus 4s squared. Now you might be looking at the one above and thinking, well, can I group this? No, not really. Maybe this is actually a difference of 2 squares here. That might come in handy later. Then what do I do with all this? I can pull a 4 out, I can pull an s out, but what's all that going to look like? Well, I want to draw your attention to this piece right here. If I factor out the negative and flip the sign of all of those, I end up with a perfect square trinomial. Remember that pattern? And a perfect square trinomial, the result is a squared plus twice the product of a and b plus b squared. So that would mean it's t plus 2s squared, right? This is the factor for this. But that still leaves me with this difference of 9p squared. And this is going to blow your mind. That should be here. Sorry. This is the factor of that squared, right? T plus 2s squared, because this is a perfect square trinomial. And this is the difference of this square, and look at that square. This, guys, is the difference of 2 squares. It just looks weird because that's 2 pieces. Which means if I take the square root of 9p squared, that's 3p, plus minus the square root of t plus 2s squared, which is t plus 2s, I now have the factors. This is one of the toughest ones to master because it's hard to recognize. So first, I factored out the negative, created a perfect square trinomial, factored it. Then I recognized the fact that this is the difference of one square and another square. Square root of this goes in the first position, plus, minus, square root of that goes in the second position, plus and minus. Anyway, that's example 4. For today, it looks like you're only going up to number 20 anyways, so you might not get to real hard ones, but we'll get into those more later.